that Bowman's capsule, the structures with in the Bowman's capsule that helps things get released. You said them in class the other day. The fenestrated.
The
fenestrated pores. And less than what goes through into the filtrate as the blood is being filtered? Less than what weight?
70,000.
Well, but we're going to go with 70,000. One book says 50, one says 70. We're going to keep it as 70,000. But why would something small, does anybody remember why something small like albumin would not get through? What was the term? It's a positive charge.
It's a negative.
They call it the shield of negativity that doesn't allow it to pass. And when we get to the dipstick, albumin is the main thing that's detected on the protein dipstick. Okay? What about the two pressures? Hydrostatic? Big what to small what? Okay, and then oncotic? What is unfiltered what that remains in the bloodstream that kind of draws water into it? Sodium, albumin is probably the biggest thing. Unfiltered proteins. Sodium is more, I don't know, an element, not a protein. But that remain in it, draw in water, which helps. Your goal is to maintain a good enough pressure that the same amount of blood is filtered regularly. So you have oncotic and hydrostatic. What's the third thing? What system is the third thing?
RAS.
RAAS, so renin, aldosterone system. Well, sodium is what it's retaining. So tell me what senses there you have low blood pressure, low sodium level? The macula densa and the juxtaglomerular apparatus. And then what does it release? What hormone? Renin. And then angiotensin goes where? Because to become angiotensin 1, to become angiotensin 2, then releases what hormone? To absorb the sodium.
ADH.
Aldosterone. And then what's the other A to reabsorb more water?
ADH.
ADH. So the RAAS system. So you have the structures of the glomerulus and the Bowman's capsule as 1, 2, hydrostatic and oncotic pressures, 3, the RAAS system to help you retain more sodium and thus retain more water. That all helps filtration. So then tell me, let's do our little chart. Tell me what is passively reabsorbed everywhere but the ascending loop.
Water.
Okay? And then tell me what is passively reabsorbed. What other two substances? Urea, do you remember where? 2 places.
And the ascending,
Okay, proximal and ascending. What's the last one?
sodium and ascending.
Okay? So that's the passive. Okay, so active, think about active. In the proximal, you have the glucose, amino acids, and salt, primarily sodium chloride. And then what are the other 2 active?
Sodium and chloride.
Where's chloride?
Chloride is in the ascending.
Ascending, and then where's sodium?
Distal.
In the distal. So this little chart, you want to know that's in your PowerPoint too, because you're going to fill out a chart on those. Okay? And then tell me about what you're going to do in your bloodstream to maintain toward the alkaline side of 7. What's being reabsorbed in the bloodstream? Bicarbonate. Okay? What 2 substances are taking the excess hydrogens out and putting them into the urine while you have an acidic urine? Ammonium and phosphate ions. Okay, so NH4 plus and H3PO4 negative. So that is secretion. Okay? And then what else was on that study guide? But that is the big one, filling out what helps filtration, what chart you'll fill out on that passive and active reabsorption, and what are the 3 processes involving bicarbonate, ammonium ion, and phosphate ion. Yes?
What would the vacuum densa produce from?
That macula, the afferent arterial plus the cells of the distal form the glomerular juxtaglomerular apparatus, and that's what controls that you have low sodium, that renin is produced. And once your sodium level gets back up, the renin, it has a check and balance, so then it stops being produced. Okay, so that whole apparatus senses that. Okay, so let's end there, and tomorrow, what we're going to do, the first practical starts at 8, the second group starts at 9:15. That's going to be our lab for today, for the day. Then before lunch, we're going to do physical, then after lunch, we're going to do chemical. Because chemical, you need to understand chemical in more detail than the little bit we tested you on, knowing what goes with what generally. When we get to the chemical, you're going to have to know what is pathological with each chemical. You're going to have to know its key reaction piece, like diazo goes with bilirubin, nitroprusside goes with ketones, and you're going to have to know what could cause a false positive and a false negative. So you're going to have to know a lot more about the chemical for that test. So I want to break before we do, I don't want to just say physical and then do chemical. You want to pay attention to half the chemical. So that'll be our plan. We'll do both practicals, do physical, break for lunch, and then we'll do chemical, and that'll be our day tomorrow. I won't start the cold agglutinin. Can't remember, I got the week 3 schedule. I think I sent it to you already, didn't I?
Yeah.
Week 3 and 4, I think I emailed it to you, all of you and Barb. And week 4 is when I have to be gone from Wednesday on. That's why I'm doing 12 hours the first 2 days. So look that over, and then we will also end looking that over tomorrow. Okay, so if you